Hello, this video is to help you with the Chapter 8 Tech project. In this one I'm going to look at Part 2. So I'm going to scroll that so it's near the top. We're going to use, let me lower that a little bit, we're going to use the application confidence interval sim for the means, which is in the StatSims folder. So I'm going to go ahead and open that up. So confidence interval for the means. I'll bring that into our window. And the first thing it says is to enter your name in the text box, so we should always do that first thing so it locks in. And then select the normal distribution for the population. That's already been selected. Enter 13 for the sample size. I'm going to just do something a little different, so I'll do 11. And let's see what's next. Enter 975 for the number of trials. That's what you should do, but I'm going to enter 873. I'm picking slightly different numbers here so that my answers aren't giving you the actual answer but just an example. And let's see what's left. Set the confidence level to 95%, so you could change that right here to 95. I'm going to leave mine at 90 again just so that I have an example that's not identical to what you would be doing. Alright, so that's everything for A. No need to capture that window or anything, that's just a setup step. And then part B, have the requirements been met for finding a confidence interval for the true mean? So when you're doing confidence intervals for a mean, you always want to start out thinking about the sample size, and in this case 11 or 13 as you have is less than 15, which is a small size sample. So typically we'd end up saying we hope our population is normally distributed, but you don't need to hope when you've already selected your population to be normal. So when you write up your requirements, you'll talk about what shape the population is instead of what you hope it to be. So just throw that up there real quick when you're doing the two. I'll let you write it up, but there's no reason to talk about the word hope because the population is known. Alright, what's next? Use the confidence level to calculate how many of the 975 confidence intervals you expect to contain the true mean. Show your work and write your answer as a decimal. So let me pull that back up again and bring a calculator in as well. There's not much work to do here. If I'm 90% confident that I'm going to have success when I do something, and then I do that something 873 times, I should get right answers 90% of the 873. To figure out how many that is, I do the 873 times 90%, which I would enter as a decimal, and press enter, and I get 785.7. So that's about how many to expect. I'm computing what the average number of successes would be, so it's okay that it's a decimal. I'll just make sure I use the word about when I write it up. So I'm going to pull this off to the side so I can still see it when the report comes up. For part C, I would just show the work of 873 times 0.90 is equal to 785.7, and then I would say something like, therefore I expect about 785.7 of the intervals to contain the true mean. And your answers will be different because you have different numbers, but it should be the same idea, and leave the decimal in there. Alright, so that takes care of C. And let's look what's next. So let me scroll this up some more. So click the Compute One button several times until you see at least one interval that does not contain the true mean. Pay attention to the relationship between yes and no on the interval tracker and the graph, and then click Automatic to finish. Alright, so let's make that happen. So it said to click Compute One, and we've talked about this in class, but this is your sample mean, which usually misses the true mean, which is the dashed line. But as long as the whisker hits the dotted line, then the true mean is contained somewhere in our interval, so we're getting a yes there. And this one, the whole graph, including the whisker, did not intersect, so that's a no. So that's what they're talking about up there in terms of paying attention. Like, you can quickly look at the graph and see this is a no and that's a yes without having to come over here and look at all the numbers. So I'll go ahead and just fill the screen, which is 20 of them. And then I have a few no's, right? Here's a no, there's a no, there's a no. So we'll capture those later, but we do have some no's. If you, for some reason in your first 20 don't have any, you can scroll down and find some that are no's. There's definitely going to be some no's in there as long as you didn't use 100%, which isn't an option. So we know you're not going to do that. All right, so there's nothing to do here in terms of the report, so we're just going to click automatic and let this run. Let me pull this up a little higher so you can see the bottom. So we're going to go till there's 873 of them. We're getting there pretty fast. It'll slow down at the end, throw the last in with a little slow down drama. And we expected around 90% of them to be successful, and I got 90.72%. So first thing we're going to do is get a screen capture of this. Let me just click up here to see what F says. So use Alt Print Screen to capture the window, and then click Redraw if your graph disappears. So we do know that if we click Alt Print Screen, generally we have that happen. So there's a Redraw button to get that back. Even though it does say to use Alt Print Screen, I would suggest that you go ahead and go with the snipping tool here. So I'm going to pull that up and move it kind of up here and click on New Snip. And I'm going to use the snipping tool to capture this window. Alt Print Screen is fine, but one of the things you were told to do is circle an interval that was a no. So if we're in the snipping tool, we have the pen tool, and I can go up there and circle one of the no's. Pretty funky circle, but still it's taken care of, and I don't have to worry about that later by hand. So edit, copy, and then go to our report, and we can paste that in. And what letter was that telling us to do that? Part F. So actually don't need a part E. Get rid of that. And part F is the graph. Put it on its own line. It's going to probably come out pretty big. Can make it a little smaller, but there's a lot of kind of fine print here, so we don't want to make it too small. And then at this point that got separated from its label. There's not much of problem number 2 on the previous page, so I'd probably just hit enter and bring the whole thing down and have it be on this next page. And then part G is a pretty quick finish here. On that one, they want us to say what percent really did contain the mean. And so to do that, I'm going to look at the percent that really contained the mean, and they're saying that 90.72% of the 90% really contained it. So if I bring the calculator back in here, turn that on, and add 873 times 0.9072, your numbers are going to be different. It says 791.9856, but really what this represents is if I were to scroll through here, that's just how many yeses there are, and that can't be a decimal, it has to be a whole number. So the reason this is coming out as a decimal is just due to the rounding error on this percentage. So round this not up, not down, but to whatever's closest. So in this case, because it's a 9, I'll round up to 792. So I'm going to slide this out of the way so I can still see it, but I want to write that into the report. So 873 times 0.9072 was equal to, and I'll go ahead and use my equation editor here, insert equation, and then I can grab approximately equal to 792. Actually, I guess it said to use the decimal, so let me squeeze that in here. It said to show the decimal, I think. So 791.9856, which is approximately 792 of the intervals. So it's going to come out a little different than what we expected. We thought there would be about 785.7 of them, and we got a few extra, but that's probably just random variation. Let me go check in there and just make sure there's other stuff, not other stuff we missed. So it can't be a decimal value, but show your work including the decimal. We did that. And then I didn't answer this question right here, and I'm not going to type it up now, but I will show you. So why was the one marked a no? And that's part E, so I guess I'll need to squeeze that in on the report. Need an E after all. So part E, and then I'll let you type up the explanation, but why was this a no? Well, the true mean was 20, and the entire range of this interval is over 20. The lowest number that's in this range is 20.5408, and even that is bigger than 20. Everything else in the range is bigger as well. I know we had some other no's in there. Here's one where the entire range is under 20. The high end is 19.224, and that's underneath the 20. So remember, this isn't just two possibilities for what the mean could be, it's a whole range, but this entire range is over 20, that entire range is under 20, so that's why those are marked as a no, and you would write an explanation something like that right here. Hopefully that's helpful for you with number 2. Good luck.